Hello, Mrs. Leganke here, going over some volume formulas with you. It says for number 1, what do each of the variables represent in the equation that you see? So V, right here, V stands for volume. You know, that's how much something would hold or contain. And then notice that the B is capital B. We've talked about this in class. The capital B stands for the area of the base. Okay, so that's an important distinction. It's a capital B, so that's the area of the base. And then the letter H, you probably know, that stands for the height. So that's the distance between the base, from the base to the top. Okay, so this formula here can be used for a lot of three-dimensional figures, but we usually use this one for a rectangular prism or a cube. I'm just going to say prism. Okay, next it says to sketch this figure and label it with dimensions you choose and then calculate the volume. So let's go ahead and sketch a prism. So to sketch a prism, begin by creating a rectangle and then an overlapping rectangle that's similar in size, and then you're going to connect the vertices there. Okay, so there's my prism that I sketched, and yours probably looks better than mine. Let's go ahead and put in dimensions of our choice. So I'm going to pick something that's kind of easy to do. So I'm going to do the maybe 8 here for the length, 6 for the width, and I'll make the height 4. Okay, so I'm going to then calculate the volume. So I write down the formula, and then I substitute into the formula. So the base here is a rectangle. To find the area of a rectangle, remember this means the area of the base. We do length times width, and then I'm going to multiply that by the height. Okay, so I'm going to go the length times the width times the height. So 48 times 4 is 192, and then I can say units cubed, or cubic units. Okay, and you were allowed to choose dimensions, so if you want to change those, you can. Okay, here we have another formula where we have a third times pi times the radius squared times the height. It still has a V. The V stands for volume, so you're going to fill in volume in the first space. And the R will stand for radius, the radius of a circle. And then H has been standing for the height. And we use this formula, a third times pi times radius squared times height. We use this for a cone. Okay, so we're going to sketch a cone. We've done a little bit of practice with this, sketching a cone. You're going to kind of take like a flattened out oval and put a point and then connect down to that point. Okay, and then inside the cone we usually kind of identify the radius, and then we'll tell the height. So we can do dimensions that we want. So for my cone, I'm going to say that I'll say the radius is 3, and then the height I'm going to say is, let's go with 5. Okay, so the height from here to here is 5. Okay, now I'm going to write that formula down and then substitute in the values. Okay, so a third times pi times, I said the radius is 3, so times 3 squared, and I said the height is 5. Okay, so now I'm going to save the pi for last, and I'm going to do 3 squared times 5. That's going to be 9 times 5 So that's 45. And then a third of that is the same thing as kind of dividing that by 3. So 45 divided by 3. Okay, so that's 15. So I get 15 pi. And then now here's your choice. You can use, it doesn't say what we're using for pi, so I can use the pi key on my calculator, or I can use 3.14 for pi. So if I do the pi key, 15 times pi, I'm going to get 47.123, and it goes on because it's irrational. And I can round this to the tenths place, so that will be 47.1. If I used 3.14 for pi, I would get 47.1. Okay, so 47.1, and then make sure we do our labels. So units cubed. Sorry, that's messy in the corner there. Okay, so just substitute into the formula and then carefully calculate. Ooh, okay, here's another formula for us. This time we have the fraction 4/3 pi r to the third power. It still says V equals, so we know that the V is going to be for volume, and the R is still going to be for radius. And when we see this formula, this is used for a sphere. If you didn't know, a sphere is just like a ball, like a basketball. We're going to sketch the figure and label it with our dimensions. Okay, so to sketch this figure, we're going to do just a ball, and then we can kind of put that little oval inside it to make it look a little bit three-dimensional. And then we're going to need the radius, so the center of the circle to the edge for our radius. Okay, and then we can choose any radius that we want. So I'm going to say right here that the radius is, let's go with 2. Okay, so write down your formula. 4/3 pi r cubed, and let's substitute in 4/3 times pi, and the radius I said was 2, so 2 cubed, or 2 to the third power. Again, I'm just going to hold off, save my pi for last. Do my exponents next, so 2 to the third power, that means 2. Right here, that means 2 times 2 times 2, which is 8. So V equals 4/3 pi times 8. And then I'm going to do 4/3 times 8. So a couple different ways you could do this. So 4/3 times 8, if you remember when we multiply fractions, we can just set it up like this and then just multiply across. So 4 times 8, we get 32 over 3, and then do 32 divided by 3. So we get 10.6 repeating, and then we're going to times that by pi. So we can say V equals 10.6 repeating, and then times that by pi. So times pi. You can either use 3.1 for pi, or you can use the pi key. So I get about 35.5 units cubed. Okay, again, that's because I chose the radius of 2. Okay, and for the last part, you're going to think of cake design, and you are in charge of ordering a cake for your friend's party. Yum. And Cassie's Cake Company offers 3 designs. So look at the different designs, and they're all for the same price. So we want to get the most cake for our money, I would think. We want to find the greatest volume to see what cake we should buy. So, right away, I'm kind of drawn to this cake here. I think kind of like the cylinder shape. But of course, it's style preference, and we want to see how much volume each cake will have. So, design A, do you see the 2 shapes? We have, right here, we have a rectangular prism this bottom shape right here, and then we have a cylinder up top. So we want to do the volume of each one. Okay, I'm going to start with the rectangular prism. And remember, that was the area of the base times the height. So looking here, I'm going to do the base, the area of the base. It's a rectangle, so I'm going to do 14 times 12, and then times it by the height of 7. Okay, so for the bottom piece, so 14 times 12 times 7 is 1,176 inches cubed. Now I'm going to go ahead and write that right in the cake. Inches cubed, okay. And then let's find the volume of the cylinder, this piece up top. And that, if you see on your formula, on your sheet here that we used, is pi r squared h. So V equals pi times the radius, which is 5 squared, times the height, which is 6. I'm going to go ahead and use the estimate of pi, 3.14, times 5 squared, which is 25, times 6. So let's go ahead and calculate all that. 3.14 times 25 times 6, and I get 471 inches cubed, and I'm going to write that right in here, 471 inches cubed. Okay, so now all together, how much volume is this cake? We're going to add these two numbers together. So 1176 plus 471. So this cake 6 is 1,647 inches cubed for its total volume. Okay, let's move on to the next cake and see how big that one is. Design B are both rectangular prisms. Okay, so we want to do, so the area, the base times the height. We're going to do this twice. So I'm going to start with the top piece. Okay, so it looks like it's 8 by 8 by 6. So 8 by 8 by 6. 8 times 8 times 6. So 384 for the top piece. Cubic inches, or inches cubed. I'm going to write that right inside the cake. Okay, and then the bottom piece, let's see, it is 13 by 10 by 6. So 13 times 10 times 6, which is 780 cubic inches. 780. Okay, and then to get the total, we're going to add those two together. So this seems kind of small compared to the last one. Let me see. 1,164 cubic inches for this one. Okay, wait, let me see what the last one was. Yeah, this one's a little bit smaller. So far the first one is in the lead. Okay, and design 3, which I liked from the beginning, I liked the cylinder shape. Just seems a little fancier to me. So a cylinder, the formula was pi r squared h, and we're going to have to do that twice. Okay, so I'm going to do the top, the smaller one first, this one right here. Okay, so we're going to do pi. I'm going to use 3.14 for pi just to estimate it. The 3.14 times 6 squared times the height of 3. Okay, so this is 36. So 3.14 times 36 times 3. And we get 339 and a little bit here, 0.12. Okay, inches cubed. So I'm going to write that right here. Okay. Okay, so that's the top piece. So the bottom piece looks much bigger, so let's see what we get here. I'm going to use 3.14 for pi, and 8 is my radius, so 8 squared times the height, which is 5. So this is 64. So 3.14 times 64 times 5. All right, and that is 100 or 1004.8 inches cubed. Okay, and then the last step would be to total that up. What's the total volume for this cylinder shaped cake? So add that up. Okay, let's see. 1,343. Oh, I forgot to write. I wanted to write this measurement in here. I don't know. I just like writing that in there. Okay, so now let's see. Let's compare and make our final statement here. Which cake we're going to go with. Okay, so now there's a little space there to write down all of their total volumes. And, well, if I have to choose to get more cake for my money, I'm going to have to go with choice A. Now, I do like the look of design C, and that would be the second greatest volume, so I could justify that I would want that because I like the look of it. But if I'm being asked, like, more cake for my money, I'd have to go for design A. So you go ahead and write your response here and why you would choose that answer. So something like, I should order design, and then you choose and tell us why. Okay, thank you.